Hello students, welcome to Focus Math Plus. In this session, we are going to discuss chapter 2, which is the introduction to the linear polynomials. As you know that this chapter comprises of 6 exercises, and in today's session, we are going to look into the introduction to polynomials as well as discuss the 4 questions from exercise 2.1. So let's get started. So before we step into the introduction of polynomials, it's important that we know what's algebra because this is the basics of polynomials. So algebra is a branch of mathematics that uses letters. So if you see these letters A, P, M, N, it could be anything. It could be any letter from A to Z. So if you see these letters in a mathematical statement, which means you are solving problems related to algebra. That's it. Okay, so algebra helps us represent real life situations, solve problems, find unknown values, and generalize patterns. So, how would you represent real life situations? Say, for example, if you are buying a pen and each pen cost varies, right? So, if you want to buy 5 pens, you don't know the cost of each pen. So, if it's going to be represented as C, so 5 times C. So, if the cost of each pen if the cost is rupees 5, then it would be 5 times 5 that would give you 25. So if we do not know the cost, we represent it with a letter which is also called as an unknown or a variable. So when you see these letters, you should understand that you are solving problems related to algebra. All right. The next thing is about The next thing is about equations and expressions. So this is the next basics that you need to know, all right? So first, you know that what's algebra. If you see any mathematical statement which has letters from A to Z, you have to understand that you are solving problems based on algebra, all right? So I hope that's clear. The next thing is equation and expression. Okay, expression, like as how we have facial expressions, math also does have expressions. So we have these two terms, for example, 5x take away 17. So we have numbers, we have constants, we have coefficients and the variables. So what is the difference between equation and expression? I shall be discussing these key components in detail. So you could see that there is an equal sign here and there's no equal sign here. So that's the only difference. So if you see an equal sign, that represents an equation. So we see that we are solving an equation, okay? But if you see no equal sign, which means that that's an expression. And in that case, we would say that we are simplifying an expression. So the terms simplify and the term solve. So for an equation, we say that we are solving an equation because we're going to find out its value. But for expressions, we're going to simplify it, look more easy to understand. Okay, so just understand the next basics that if you see an equal sign, we call that as equation. So you could see E, Q, U, A, right? And if you just add an L, so that will be equal. So equal sign. So equation has an equal sign, whereas an expression doesn't. Okay, so you could see that an expression doesn't have an equal sign, an equation does. Okay, so I hope the definition of algebra is clear, and also the definition of expression and equation and the difference between the two is also clear. Now let's move into the next basics. Here, we're going to look into the key components in an expression. Okay, the basic terminologies in algebra. A variable, a letter that represents an unknown value or a quantity that can change. So suppose, for example, the previous example that we saw, the cost of a pen could differ, isn't it? So in one shop, the cost of the pen might be 5 rupees. In another shop, it could be 6. Correct. So these will differ. The value, the price of the pen would differ. So in that case, we would write it as a C. So C is a variable which is unknown and it can vary. Since because it can vary, which means that which can differ, that's the reason we call it as a variable, which means it can change. It is subject to change, right? So based on that, we call that as a variable. So can it be just X? No, not always X. It could be any letter. So make it clear that it could be any letter from A to Z. but you have to write that in lowercase letter, A to Z. So it could be B, it could be P, it could be M, it could be any letter. It has to be lowercase letter. We represent variables with lowercase letters. All right, I hope the variable is clear. It can change, and that's the reason we call it as variable. The next thing, that a term, a single number or a variable, or a number and a variable multiplied together. Okay, so you could see that in this expression. So we just have one term, 5x. We just have one term in this example, which is -3, and here 7y. All of these are terms. Okay, how would you distinguish between the two terms? For example, if you have an expression 7x plus 5y, take away 7. So in this expression, you could see that the operators addition and subtraction, correct? So these distinguish between the terms. So this is one term, this is another, and this is another. So how would you distinguish? You have to look for the operators addition, the addition operator, and the subtraction operator. So you always have to look to count the number of terms. So this is the first term, this is the second, and this is the third. So this polynomial consists of 3 terms. So we distinguish it by the addition and subtraction operators. That's it. Okay. The next one, coefficients. So coefficient is a number or a factor of a term that is multiplied by a variable. Suppose, of course, you know what are variables. Variables are letters, right? So it could be any letter. Say, for example, S. Suppose if it's just S, what is a coefficient? There's nothing, but it definitely means something, isn't it? So it is nothing but 1s. So the coefficient of s is 1. The coefficient of 1s is 1. The coefficient of 5y is 5. All right, so most of the time we don't write this one, so we just write it as s, but it's understandable that it is 1s. The coefficient of 5y is 5. The coefficient of 7x is 7. Okay, so it is a numerical factor of a term that is multiplied with the variable. So it will always exist with the variable only. Only then we call it as a coefficient. Okay, so what is the sign that exists between the factor and the variable? Suppose if I take 5y, so the operator in between 5 and y is multiplication. It is always multiplication. In this example, 5x, it is 5 times x. So it's multiplication that exists between the coefficient and the variable. So if you have to substitute for the variable, you have to always multiply. Okay. So remember, a coefficient would not be free of any variable. Whenever you see a variable with a number, that number alone is called a coefficient. Okay, now let's move on to the next component, which is a constant. A term with a fixed value without any variable is a constant. Okay, this is not subject to change. It's not going to change. It's a constant value. It is for sure. So in this example, it is 7. It can be any number. It's just a number, 25, -17. All these are constants. They would not have any variable with it. And the next, of course, the basic operations, addition, subtraction, multiplication, division, and the power, the exponent of the number, x squared or x to the power of 3, all of these things. Okay, the last thing is the like terms. Okay, terms that have same variable part and also raised to the same power. Okay, what does it mean? So what are like terms? Like terms will have same variable, so you have to ensure that the variable is same and the power or the exponent of the variable is also the same. Suppose, say for example, 5x to the power 2 and 7x to the power 2. All these are like terms because they have the same variable x and they also have the power as 2. So the exponent is also the same, the variable is also the same. Suppose, say for example, 5y to the power of 3 and 2y to the power of 2. These aren't like terms because although they have the same variable y, but they have different powers. So these aren't like terms and so they are called as unlike terms. These are like terms and the one above are unlike terms. Okay, I hope that's clear. So let's move on to the next few basics before we start discussing the questions on the exercise. Polynomial. What does a polynomial mean? A polynomial in algebraic expression consisting of variables and coefficients involving only non-negative integer. Now here we have the term integer. What does it mean? So integers comprise of what all numbers? Yes, you know the numbers on the number line without decimals. It shouldn't be containing decimals. We have 1, 2, 3, 4, 5, correct? It also has -1, -2, -3, correct? So when you add negative numbers, we call it as integers. So only these numbers are natural numbers. The numbers starting from 1, 2, etc. and goes on. These are natural numbers. And when we add 0 to the natural numbers list, those numbers are called as whole numbers. And when negative numbers are also added to the whole numbers, it is called as integers. Okay, so when you find integers, which means when you find negative numbers, those aren't polynomials. So you see 1 over x, and this is square root of x. I hope the definition to polynomial is clear. Polynomial is an algebraic expression. It could have variables. Those are letters from A to Z. It could have constants. Constants are just plain numbers. It could have coefficients. Coefficients are the numbers which are multiplied to the variable. It could have operators, but it shouldn't contain negative powers and also fractional powers. Okay, now let's look into the types of polynomials. The first of which is the monomial. One term, an expression which has one term is called a monomial. And an expression which has two terms, you could just distinguish between the two terms with the positive operator in the middle. So you could see x is one term and 5 is another. With the next example, you could see that 3y is one term and 7 is another term, -7. So there are two terms. So an expression which contains exactly two terms are called as binomials. All right. And the expression which consists of three terms, like say x squared, in this example, we then have 4x and 1, -1. So it consists of three terms. In the next example, also you could see 2y squared is one term, -y is 1, and 3 is the third term. So there are three terms. So it has exactly three terms, and expression which has three terms are called as trinomials. More than three terms, we call it as polynomials. As you could see, it has 1, 2, 3, 4. So those are the keywords: monomial, binomial, trinomial, and polynomial. One term, two terms, three terms, and more than three terms. In an algebraic expression, the power of the variable also appears. As you know, an algebraic expression is a one. If we talk about algebra, you just have to think about letters. Yes, algebra is nothing but a mathematical statement which consists of letters from A to Z. So suppose if you have an expression, say 10 take away 7 plus 2 minus 1. It has all numbers, right? It has all of the terms to be as numbers, and hence this is called a numeric. It's called a numeric expression. Because it doesn't have an equal sign, it's called a numeric expression. If it has an equal sign, it would be called as a numeric equation. Now, this is a numeric expression. If you have, like, say, 10x minus 2y plus 3, then this would be called as an algebraic expression because we see letters. Letters are variables, and those are used to represent unknown values, right? So x and y are variables, and this is an algebraic expression. So it also does have powers, right? As you could see in this expression, the power of x is 2. The highest power is 2. 5x, x has the high power as 1, and 1 has no variable. So the power of the variable x is highest is 2. In the next expression, 5y to the power 3, here the variable y has the power 3 in the first term. The second term, the variable y has the power as 2. So the highest power is 3. So the highest power of y is 3. And in the next one also the same thing. Okay, we have y to the power of 3. And the coefficient of y to the power of 3 is 5 because 5 comes along with y to the power of 3, so 5 is the coefficient. The coefficient of y square, you see nothing, isn't it? But it is 1y squared. We don't write the 1, so how do we call an apple? Do we say it as one apple? No, we call it an apple, isn't it? So we don't mention one apple. So it's an apple. So likewise, we just do not write the 1 along with any variable. So it's understandable that it is just one variable that exists. So it's 1y squared, so it is 1. The coefficient of y is 2 because it is 2 times y. And the constant is a number without any variable, so it's -1 in this case. Now this is what is next introduced, which is most important, and it's called the degree. The highest power of the variable is called the degree. Okay, let's look into a few more examples. Now here, as you could see that this expression, the variable y, 5y to the power of 3 or 5y cubed, y squared plus 2y minus 1. So you could see that the variable is just one and it is y. And each variable, each time it has a different power. The first term, the power of y is 3. In the second term, the power of y is 2. In the third term, the power of y is 1. What is the highest power? The highest power is 3. So the highest power of y is 3. Hence, it is a polynomial of degree 3. It's easy. You just have to take the highest power and mention as the degree, right? And this kind of polynomial, we call it as a cubic polynomial. Okay, let's look into the second example. The second expression, x squared plus 5y minus 1. So we have plus 1. So we have the highest power of the x as 2 because here the power of x is 1. Because the highest power of x is 2, it is a polynomial of degree 2, and this is called a quadratic polynomial. The next expression, 3z plus 7, in this we can see that the power of z is 1. So the highest power is 1, and hence the degree of the polynomial is 1, and it's called a linear polynomial. A linear polynomial because the power of the variable is just 1. The power will not be mentioned, but it's understandable. If you see no power, say 5x, if there's no power, which means it is 1, we don't write the 1. As we don't write the coefficient, we don't write the power as well if it is 1. So it's understandable the power is 1, and hence this is a polynomial of degree 1, and it's called a linear polynomial. And the last thing, 8 is a constant polynomial. It doesn't have any variable, so no degree. The degree is 0. Okay, now let's look into these key components, a linear polynomial of degree 1. So you can see that there exists just one variable, which is x, and the highest power is 1 because it has no other variable. It's 1, right? So there are two terms. 3x is one term and 5 is another. So there are two terms in this expression. This is an algebraic expression and it has two terms. Next thing, 3x is a variable term because it has a variable x along with it. 5 is a constant term because it doesn't have any variable. So it's a constant term. The variable used is just x, and the coefficient of x is 3 because 3 is multiplied with x. So 3 is the coefficient of x. Okay, and the degree of this polynomial is 1. Everything has been given. The terms are 3x comma 5. The coefficient is just 3. The constant is 5. The variable that exists is just x, and the degree of the polynomial is the power of the x, which is 1. So the degree of the polynomial is 1. Are you all good? Coefficients 3, 5. You have to also take the negative sign. -5, +2, -7, and a constant is 6. Suppose if you've been asked the coefficient of x cubed. So the coefficient of x cubed is -5. So you have to just take this entire thing. What is the coefficient of x squared? The coefficient of x squared is just 2. And what is the coefficient of x? The coefficient of x is -7, right? So the variable represented is just x, and there are how many terms? How many terms could you find? 1, 2, 3, 4, and 5. There are 5 terms in this expression, and this is an algebraic expression. And what is the highest power of x? As you could see, the highest power of x is 4, right? So therefore, this is a polynomial of degree 4. I hope that's clear. Okay, now let's discuss the 4 questions from exercise 2.1. The first question is, find the degree of each of the polynomials given. So as you could see, the first polynomial, 2x squared, take away 5x plus 3. The first term has 2x squared, and the highest power here, it is 2. And here the power of x is not mentioned, which means it is 1. And this is a constant term. It doesn't have any variable. So 2x squared. So what is the highest power? 2. So the degree is 2. That's it. It's easy. It isn't difficult at all. The next one, here we could see the next polynomial, y cubed plus 2y take away 1. We see that the variable given is y, and the first term here, y has 3 as its power. And the second term, y has 1 as its power. So the highest is 3. So the degree of the polynomial is 3. And this is a constant polynomial. It's just a constant, and so the degree is 0. And here you could see that for polynomial 4z take away 3. Z has no power, which means it is 1. If nothing is written, it's understandable that it is 1. So the degree of the polynomial is 1. So you could just represent it right clearly that the degree of a polynomial is the highest power of the variable. And you could mention the highest power of x is 2. So the degree is 2 in the first polynomial. In the second polynomial, the highest power of y is 3. So the degree is 3. And in the third polynomial, this is a constant polynomial, no variable, so the degree is 0. And in the last polynomial, the highest power of z is 1, and so the degree is 1. I hope that's clear. Now let's move on to the second question. Write polynomials of degrees 1, 2, and 3. So here, this is an open question. So you could write any kind of example. It's up to you. You could just write as you like. Okay, but it has to adhere to all the rules which are being given and the definition of polynomials of degree 1. Okay, the first example, polynomial with degree 1. So you could see that the variable x, it has the power as just 1, right? So this is 7x to the power 1 plus 9. So this is a polynomial of degree 1. You could also write it as 5y minus 2, 9m plus 7. So all these represent a polynomial of degree 1 because the power of the variable is 1. You could write anything, but it has to be accordingly written. Next one, the polynomial of degree 2. Of course, it's called a quadratic polynomial, and you could see that the highest power of x is 2. So this is called a polynomial of degree 2. You could also write your own examples, need not just this, it could be anything. Say for example, 6y squared plus 5y minus 7. The highest value, the highest power of y is 2. So this is a polynomial of degree 2. And the last one, the polynomial of degree 3. You could see that the polynomial here given, the variable is x and the highest power is 3. So this is the polynomial which represents the highest power as 3. And so this is the polynomial which is of degree 3. That's it. So you could write anything, but it has to be having the highest power as 3. Now let's look into the third question. What are the coefficients of x squared and x cubed in this polynomial? Now what do you do is just highlight the x squared term. So it is this 6x squared, and the x cubed term, it's negative 3x to the power of 3. But we are to pick out just the coefficients. So the coefficient of x squared is positive 6, and the coefficient of x to the power of 3 is negative 3. That's it. It's a very easy question as well. So you could write it more clearly that the coefficient of x squared is 6 and the coefficient of x to the power of 3 is negative 3. Don't forget the negative sign. If it is positive, it's okay. You can just write the number. It's understandable that it's a positive number. But if it is a negative sign, take that number as a negative number and just write it along with the negative sign to mention that the coefficient of x cubed is negative 3. If you've been asked the coefficient of x, you need to mention that the coefficient of x, it is going to be, any guesses? Yes, it is negative 2, and the constant in this polynomial is 7. Now let's look into the question 4. It says, what is the coefficient of z in the polynomial? First, read this polynomial. 4z to the power of 3 plus 5 z squared take away 11. Is there any z here? No, isn't it? So you don't find any z here. So which means that the given polynomial 4z to the power of 3 plus 5z squared take away 11, there is no term containing z. So hence the coefficient of z is 0. So there's no term. We don't find any term with the variable as z, which means z to the power 1. So the coefficient is 0. All right. Since because there isn't any z term here, we have z to the power of 3, we have z to the power of 2, but we do not have z to the power of 1 because we just have a constant here. This is a constant. So hence the coefficient of z is 0. Now the last question of this exercise, what is the constant term of the polynomial? So what is a constant? A constant is a number that appears on its own. It doesn't have any variable attached with it. So which is this number? -10. The constant term is a term without any variable. So in the polynomial, 9x to the power of 3 or 9x cubed plus 5x squared minus 8x minus 10, the constant term is -10. So this is a constant. Don't forget to take the negative sign along with 10 because -10 is a constant given in this polynomial, and this is an algebraic expression. So we are done with all the 5 questions on this exercise. And here is a question from Think and Reflect from your textbook. Find the perimeter of squares with sides 1 centimeter. So there's one square with side 1 centimeter and another square with side 1.5 centimeter and another third square whose side is 2 centimeter and the fourth square whose side is 2.5 centimeter and the fifth square which has the side as 3 centimeter. What will happen to the perimeters if the size increase by 0.5 centimeter? So there exists a pattern. You can create a pattern using the letters, using algebra. Okay, drop your answers in the comments for this question and see you in the next video. And thanks for watching.